Hi. In this lecture, we're going to talk about a famous model from social science, and this model is known as Schelling Spatial Segregation Model. Schelling's model was developed by a man named Thomas Schelling, who's an economist at the University of Maryland. What Schelling was trying to do was he was trying to sort of understand an empirical phenomenon, and that empirical phenomenon that he was interested in was segregation. And two types of segregation actually of primary interest to him. One was racial segregation, the other was segregation by income. So let's look at some pictures of each. So what you see is a picture of New York City. Each red dot in this graph represents a city block that's majority Caucasian or white. Each blue dot represents a city block that's majority African American. Each yellow dot represents a city block that's majority Latino. And each green dot represents a city block that's majority Asian of some sort. It could be Korean, could be Japanese, could be Chinese American, but it's classified as Asian by the census. So if you look at this picture, what you see is incredible racial segregation, right? Now the same is true if you look by income. So here's, again, a picture of New York City. Each red dot represents someone who's very wealthy. Each light blue dot represents someone who's poor. And the moderately blue dots represent people in the middle class. So if you look at this picture, what you see is segregation by income. And it's also, fairly stark. Not as stark as the racial segregation, but it's pretty stark. So this is what Schelling wanted to understand. You want to construct a model to make sense of this. Now you might say, we don't need a model. Why do we need a model? It's obvious. Look, people, maybe they're racist. People don't like to live with people who don't look like them, and that's why we get segregation. Well, that's what Schelling set out to explore. And he set out to explore that using a model. So what kind of model does he construct? He constructs what we call, remember, an agent-based model. So remember, an agent-based model, you've got three things. You've got these agents, which in this case will be people, right? That's part one. Then you have their behaviors. You have to say, okay, what rules do they follow? That's part two. And then the third part is you just add them up. You just aggregate it, and you see what happens. When all these people are following these rules, what do we get at the aggregate level? Okay, so what's Schelling's model about? Schelling's model is about people choosing where to live. So you can think, when you think about people choosing where to live, well, you think about, okay, I'm going to buy a house. What kind of house do I want to buy? Do I want to buy this beautiful craftsman house? Do I want to buy a Spanish-style house? Do I want to live in an apartment? Those sorts of questions. Well, Schelling abstracted away from all that, and he said, okay, I want to think about this in a different way. I want to think about people living in a city, living in some place, and deciding, should I stay here or should I move? So here's how he did it. He thought of each person as being located on a checkerboard. So what he did is he thought of the whole city, whether it's New York or Detroit or Houston, as a giant checkerboard. And each checkerboard can have a person living there or it can be blank. So in this picture that we see here, right, what we've got is we've got a person living at X. So this is our person right here. And there's 8 neighbors, 1 through 8. And one of those neighborhoods is blank, right? If you look at number 3 here, right, there's no one living there. So she's got a total of 7 neighbors. Now let's let red represent rich people and gray represent poor people. So this is a rich person. And if we look at her, she's got 3 neighbors who are rich like her, but then she's got 4 neighbors who aren't. So in total, 3 out of her 7 neighbors are the same as her. And she's got to decide, okay, is 3 out of 7 enough? If 3 out of 7 of my neighbors aren't like me, should I stay or should I go? Well, this is where Schelling then writes down the rules, and he calls this a threshold-based rule. So each person has a threshold, and they decide, based on this threshold, do I stay where I'm at or do I move? So one rule would be, well, 3/7 is good enough. So maybe your rule is 33%. So if 33% of my neighbors aren't like me, I'll stay, but if fewer than 33% are like me, then I'll move. So this woman here, she looks and she counts 3 of her 7 neighbors are like her, so she stays. But if one of her neighbors moved out, and now there were only 2 out of 7 neighbors like her, then she'd move. So this is the model. That's all there is to it. So there's people, they've got neighborhoods, and they have to decide whether to stay or to move, and then we ask, what happens? Now when Schelling ran his model, he did it using paper and pencil on an airplane, actually, and he wrote out a big checkerboard, and he just used, I think, nickels and pennies to represent the different income groups. We've got some advantages Schelling didn't have. We're going to use a computer program called NetLogo. And this is free software. We've used it before, right? So let's go to our NetLogo model. Okay, here it is, our model. Now remember, 3 parts of an agent-based model: the agents, their rule, and then the aggregate behavior. So if you look at this NetLogo model, the first thing we see here is this number up on the top, and that tells us the number of agents. So we can set this up, and we're going to have blue agents and yellow agents. We'll let the blue agents be rich and the yellow agents be poor, and they're just randomly set up on this grid. We've got a behavior, right? And the behavior rule is the percent similar wanted. So it's 30% right now. People want 30% of their neighbors to look like them. And then we've got the aggregation, which are going to be covered in these 2 graphs. So the aggregation is going to tell us what's the percentage similar, so how many people are like you in your neighborhood of 8. and then the percentage are unhappy, how many people aren't having their threshold met. All right, so we're starting at 30%, and notice we start out at 50% similar, and only 16% are unhappy. Now, 50% similar makes sense because people are randomly set out there, so half should be like you, half should be not. Okay, so here we go. If we let this run, what happens is at the end we end up with 72% similar, and nobody's unhappy. So the system goes to an equilibrium. But what's interesting about this is if you look at this, 72% of a person's neighbors are like them, even though people are incredibly tolerant. They only need 30% of the people in their neighborhood to be like them, and you end up with 70% of the people in your neighborhood like you. So here's the deep insight from Schelling's model. What you see at the macro level, segregation like this, may not in fact represent what's really going on at the micro level, because these are pretty tolerant people. Right? These are very tolerant people. All they want is a third of the people to look like them and they'll be okay. But if that's their rule, you end up with 70% of people looking like you. But what if we make them just slightly less tolerant? And so we move this up to, let's say, 40%. And we set this up. Now, again, we start with 49.5% of people unhappy, and 30% of people unhappy, but 49.5% of people are similar to you. And if we let this go, what we end up now is 80% of the people end up being similar to their neighbors, right? So you get a person's neighbors are 80% of them are similar to them. So we get even more segregation. Well, what's interesting here is if we ramp this up even more, let's say to 52%, let's just make it a little over 50%, now over 60% of people are unhappy. That's because over 60% of people have 50% or fewer neighbors like them. And if we run this, we get unbelievable segregation, right? Now, what's incredible about this is 52% isn't that intolerant if you think about it. You're sort of saying, look, I just want to be in the majority. I actually might prefer a racially mixed neighborhood or an income mixed neighborhood. But if I do that, what I end up with is 94% of my neighbors will be like me. And if you look closely at this picture, what you see is that there's sort of like little islands of empty space. The black regions are empty space between the blue and yellow regions. So these people are really segregating. Now, you could say, so this is sort of surprising, right? Again, we get this amazing result from Schelling that at the macro level we get segregation, even though at the micro level people are pretty tolerant. Now remember how we thought about why we get segregation, because we think that, well, people don't want to hang out with poor people. What if we assume that rich people don't want to hang out with poor people? So let's crank this way up, and poor people don't want to hang out with rich people. So let's crank this way up to 80%. So now people want 80% of their neighbors to be like them, and if they're not, they're going to move. Well, we should get massive segregation here, right? Even worse than before. Okay, we don't even get an equilibrium. We get this sort of completely random process, right? Everybody's still hanging out in neighborhoods where 50% of people are similar. The reason why is if you don't want anybody in your neighborhood to be like you, well, it's hard to find a place to live. Because you move someplace else, there's going to be someone who's not like you, and then you're going to want to move again. So if people really were incredibly racist or incredibly biased based on income, then we might not see the segregation. We might see people moving all the time, churning, to avoid being around anyone like them. So what Schelling's model tells us, right, again, in this really sort of very simple way, that what happens at that macro level, segregation by race, by income, by all sorts of other things, may not be, right, because of the fact that at the micro level, people are that intolerant. So the micro and the macro may not align. Okay, so that's the big lesson, right? Micro motives need not be equal to macro behavior. And in fact, Schelling has a book. The book that he's famous for is called Micro Motives and Macro Behavior, reminding us that what we see out there in the world need not imply so the macro level outcomes need not imply what we think about the micro level behaviors of individuals. Okay, so let's flesh out Schelling's model a little bit more, because one of the things that's interesting about it is what people sometimes call the tipping phenomena in Schelling's model. So remember when we set it up, only 15% of people wanted to move. So let's suppose I've got some person, they're sitting in some neighborhood, and there's only 2/7 of her neighbors are like her, so she moves. Well, when she moves, she can cause other people to move. So let's look at this person here who's sitting in a neighborhood where there's 2 of her 7 neighbors are like her. Now let's suppose that she's happy with that. She's cool with that. She's going to stay with 2 of her 7 neighbors being just like her. But what happens is this person leaves. Person number 5 leaves the system, right? Moves to someplace else because that person didn't have enough neighbors like her to feel comfortable. But when that person leaves, that's going to cause her to leave. All right? So that's an exodus tip. One person leaves, causing another person to leave. Okay? There's also a genesis tip. Let's suppose she's living in this neighborhood and she's got, in this case, right, she's got 2 out of 7 neighbors who look like her. And what happens is someone moves in to the neighborhood who's not like her. And so now she's only got 2 out of 8. And so now there's too many poor people living in the neighborhood. And she says, you know what, because of that, I'm out of here. This would be a genesis tip. Somebody moves in, causes her to move. So those are the two things that cause tips in Schelling's models. Genesis tips and exodus tips. So people moving out cause other people to move out, and people moving in cause some people who are currently there to want to move out. All right, so when you look at a city then like New York, or Detroit, or Houston, or LA, or Chicago, or Philadelphia, if you pull up maps for any one of these cities, they're going to look exactly like this. Not exactly, they have the same sort of patterns of racial segregation, in some cases even more pronounced. Now what we could infer from that would be that at the micro level, people are very racist. People don't feel comfortable living in neighborhoods with people like them. Well, what's interesting is if you poll people, if you ask them, people actually say, no, I'd like to live in a mixed income, mixed race neighborhood. Yet, they sort of may want it to be a little bit more like maybe 30-40% like them. Well, if that's what people want at the micro level, to be in sort of mixed neighborhoods, it's not what they get. What they get is pictures like this. And that's what's so surprising about Schelling's model. The macro behavior, right, the micro behavior doesn't produce sort of macro level behavior that's consistent with what they want. All right, so that's Schelling's model. And in the next lecture, we're going to go into more detail about sort of how do we measure segregation, and then we'll talk about some of the fertility of Schelling's model, how we can apply it to other settings as well. Thank you.